Welcome to lesson 3.3. Our objective is we're going to solve systems of linear inequalities. The only way to solve these is by graphing. All right, so the steps to solve them, we're going to graph each inequality separately. We're going to shade the appropriate region of each inequality, meaning for each line, you're going to shade one side or the other. And then the part of the graph that is shaded by both is your solution region. So let's just jump into example 1 here. Right, so the first thing I'm going to do, it is probably easier to graph these in slope-intercept form. So I'm just going to subtract x from both sides. And I get y is greater than the opposite of x plus 3. So that means the y-intercept's at 3, slope's at -1. It is going to be a dashed line because it's just greater than. And that means you're going to shade above it. I'm going to choose a different color for the other line. This already is in slope-intercept form. It's got a y-intercept at -1 and a slope of 1. This one's going to be a solid line. And you're also shading above it. So the part of the graph that is shaded by both is this part. So I'm just going to go back and do that part really dark. And that's it. So like your answer is this part of the graph. So any ordered pair that's in this shaded part would be a solution to both. Any ordered pair that's outside of that is going to not work for at least one of them, or maybe both, but at least one. All right, so let's look at part B. First one's in slope-intercept form, so that's y-intercept of 4, slope of -2. It's a solid line. And you're shading underneath. The other line is x greater than -3. Recall that greater than means it's a vertical line. It's going to be dashed, and it's going to go through -3. Greater than means you're shading to the right. So it's going to be everywhere in here. So to the right of the green line and under the blue line. So again, that's your solution region. Any ordered pair in that region would work for both inequalities. Anything outside of it is going to not work for at least one. All right, so let's apply this to a question with some context. It says Lucas spends at most 150 minutes a night on math and science homework. He spends at least 60 minutes on math. Write and solve a system of inequalities to model how he allots his time. The solving is going to be, graphing it. What we first have to do is write an inequality. And the first thing we're going to do is define some variables. We're going to say math is x. And y is science. So the first inequality is from the first sentence where he said spends at most 150 minutes on both. So both would be adding them together. At most would be less than or equal to, because at most means 150 minutes is the most he will do, right? He could do less than that. Can't do more than that. The other inequality says he spends at least 60 minutes on math. So that means x is greater than or equal to 60, because that's the smallest amount that he'll do on math, but he could do more. The other things to point out would be, and notice how the graph is just the first quadrant, because you can't spend a negative amount of time on homework. So this is kind of negligible, but x also has to be greater than or equal to 0 because you can't spend 0 minutes on math. It already says he's spending at least 60 minutes, so this is kind of moot because you already have the x is greater than or equal to 60, but y has to be greater than or equal to 0 as well. All right, so now we're going to graph these. So the first thing I'm going to do is subtract the x to the other side for this one, and you get y is less than or equal to negative x plus 150. I think the way that you're going to get this to fit, well, if you notice, you got to scale this, right? Because obviously you don't have 150 blocks to do the y-intercept at 150. The other thing is the numbers that we're using are 150 and 60. So making each block 15 makes the most sense because then if you scale it, like if that's 15, I'm only going to write every other. 150 fits nicely. And 60 is still going to be on the line. All right, so 150 is your y-intercept for that first equation, and then the slope is -1, meaning you're going to go all the way down and end up here. It is a solid line, so I'm going to do a solid line. All right, x is greater than or equal to 60. That's a vertical line through 60. All right, and then x is greater than or equal to 0, and y is greater than or equal to 0. So you have a vertical line here also shading to the right, so that's kind of negligible, but you also have the one here where you end up just shading in between here. So that means any ordered pair in here would work, meaning, let's just pick one. If I picked this point right here, that means he's spending 90, remember x is math, so 90 minutes on math, and this would be 45 minutes on science. That works within the constraints of what we allow, what we're set here. If you picked a point out here, 120 minutes on math and 90 minutes on science, that would break the first one here because 90 plus 120 is more than 150, right? So that's why that point would be outside the shaded region. We can also work with absolute values here. It's really no different. We're just going to graph both of them separately. So I've got y is less than 4. So that would be a horizontal line dashed through 4, which we're shading underneath of that. And then remember how to do the absolute values. First, you got to find the vertex, right? So the vertex for this would be 3, 0. So that means right 3 and not up at all. And it's got a slope of 1, so it's going to go like this. It'd be a solid line. And you're shading above. So I'm shading above the purple and below the red everywhere in here. All right, similar deal over here. Y is less than or equal to 3. Would be a horizontal line through 3. This has a vertex at -2, 5. So left 2 up to 5 here, and it's opening down. Oh, it should be dashed, sorry. All right, pretend like that part's dashed. You're above both of them. So if you're above the green and the purple, it's going to be this region up here. All right, there are 2 more graphs on here. That will be your exit ticket. So try them on the note sheet, and then you can go submit your answer on the exit ticket that I posted separately on Google Classroom. Let me know if you have any other questions.